on these more difficult binomial expansion questions. So request for question 7a first. Let's have a little look at that first. So they want to find the coefficient of x to the 10, so that'll be the number here in front of the x. Of this expansion. Okay, so that's the first question here. All right, so we'd have to start thinking about what the general term of this expansion is. In general, because it is to the power of 10, I know that if I need to use the NCR thing, it's going to be 10 here anyway. And I know that that's 3, and I know that's 2x squared. So there's our binomial, the first term, and the second term. Okay. N will always be this number up here. We'll always refer to that. Now I don't have the powers done here yet. And that's what I need to think about. So I need to make x to the power of 10. Now the only thing that's going to make x to the power of 10 is this second term in the binomial. It's going to be x squared to the power of something needs to give me 10. And now anyone want to has a guess what it needs to be? I'd say just probably most people figure this out. It needs to be 5 to make 10, doesn't it? Because 2 times 5 makes 10. Okay. So if that is 5, then I need to think about what the other one is, and then we need to look at what goes here. Well, I know this 5 would be the same as this 5, and then remember that in this one, it's 10 take away whatever that is. So it's going to be 10 take away 5. So what does that leave us with? 10 choose 5. So that's going to be from the calculator, and we'll do that in a second. So 10 choose 5. And that leaves 3 to the power of 5 and 2x squared to the power of 5. And remember, because using my rules of indices, that times that will give x to the 10. 10 choose 5, well, that's where I need my calculator. I think this is going to be a huge number. I imagine it's a huge number. 10 choose 5. I did 9 choose 2 here last. That's not going to work for me, so I'm going to do 10. Math, go over to my probability, and 10 choose 5. 252. I'm going to multiply that then by 3 to the power of 5, because that was my next part. And let's just get an answer for that. Well, that's quite large already. Okay, now I haven't dealt with that yet, but I know that these two combined is 6, 1, 2, 3, 6. Now this 2x squared still needs to be to the power of 5, which means that 2 is going to be to the power of 5. So what's 2 to the power of 5? I think it's 32, isn't it? So I need to multiply this large number by 2 to the power of 5. Multiply my two answers together. Perhaps I could have done this better. 6, 1, 2, 3, 6. Multiply by that 32. And I get, wow, it's 1,959,552 x to the power of 10. The 10 comes from 2 times 5 here. And that's the answer to 7a. So that is my coefficient. That is the number in front. And that, you don't want to do that without a calculator. All right, so that was the first requested question. You can still request a question if you want. The second one is 7c. 7c. Okay, so it's x's and y's, isn't it? So this one asks for the coefficient of the x6y cubed term, so for that number in front of the expansion of 2x squared minus 3y and to the power of 6. All right. All right. Okay, so general term first. Let's have a little look at the general. I know it's going to be 6 here anyway. I know my first term in the binomial is 2x squared, and my second term in the binomial is minus 3y. Okay. Now I need the x to be double what the y is, and I need y to be 3. Okay, I need y to be 3. So if I just start with that and see what happens, if I just go cubed here, that'll mean that y is going to be cubed in my answer. And if that's 3, means that's 3, and that's 6 minus 3. Because whatever this, that's going to be 3. Okay. And that will give 6. 2. Oh, yes. So just 6 minus 3 is 3. Okay, so that's going to be x squared to the power 3. That's going to give me the x6. That checks out. And y cubed will give y cubed. Okay, that checks out. Now it's just use of my calculator. 6 choose 3 can be done here. Okay, 20. Possibly could have known that from my Pascal's triangle. 2x, well, I already know it's x to the power 6. But that 2 needs to be cubed, so it's actually 8x to the power 6. So that's 2x squared cubed. Now, minus 3y also cubed. Minus 3 cubed is minus 27. It's going to be negative. And that y is cubed. So oops, I just squeezed it in there. Okay. All right, so I just need to combine the coefficients now. That's 20 times 8 times negative 27, and then I'll have it. 20 times 8 times, well, I'll make it positive 27, but I know my answer is going to be negative. It's going to be negative 4, 3, 20, x6y cubed. Okay, so the coefficient is that number there. So hopefully maybe 1 or 2 of you got that. Okay, any other questions you'd like me to do, or will I just move on? Okay, I'm going to move on. So one of the questions I gave you was if you were able to do these quite well, you can move on to question 9 and 10. Now, what I'm going to do is I'm going to do question 9, and then I'm going to set you some more work on the more difficult ones. So I just want to show you how you would do question 9 as my final example today. Hopefully that focuses in a second. So question 9. It asks for it says that, if you're not looking at it, the third term of 1 plus x to the n is 36x squared. Find n. And hence, find the fourth term. Okay, so that is question 9. All right, so there's a lot going on here. This time we don't know what the power is, which is a little bit different than what we're used to. They gave us the third term. They want us to find what the power is, and then once you've found the power, so that's what the hence would come in, you must have found this bit first, and you must use it. You must use it if they say hence. Sometimes they say hence or otherwise, find the fourth term. If it's hence, you must use that, and we will use it because it's a lot easier if you know what the power is. So straight away, we got to look at how we go about this, and this is going to use our problem-solving skills. Okay, so interestingly enough here, x is not the first term in the binomial. So you may notice that. It's actually 1 is the first term in the binomial x. That means the x term is going to be the one that goes up in power. So the first term of this binomial is going to be 1. I know that for sure. How do I know that for sure? Hopefully some of you have figured out how I know that for sure. First term is going to be 1. The second term, I think, might be x. Maybe? Not sure. It'll have x in it, but I'm not sure about the power of x. How do I know it's 1? Well, I could do out the general term. So the general term is always good to have. In this case, there's not as much information in the general term because I don't know n. I don't know how many it is to the power of. Okay? I'm going to try and fill the bottom in a second. But I do know what the two terms of the binomial are. The first one is 1, and the second one is x. Now, if we remember our base model one with like a's and b's and that kind of thing, and I can very quickly write that because I wrote it on the page here. For example, a plus b to the power of 5. The first term is a to the power of 5, and then it's a 5a to the power of 4b to the power of 1 plus the third term, which is crucial here, is 10a cubed b squared. Now, the coefficients won't be the same because we're not sure it's to the power of 5, but we do know that the third term, if you notice, the b power is going to be b to the power of 2 here. Has to be that because these are increasing. Starts at 0, b to the power of 0, b to the power of 1, b to the power of 2. Now in this case, it's not b, it's x, but the same thing applies. The first term is going to be x to the power of 0. The second term is just going to be x, and the third term, part of it, is going to be x squared. So this has to be x squared here, which gives me some information. It means that's definitely 2. This then is definitely 2. This is then the total number take away 2. So that's the general term of this. And we know that this is 36. That third term is 36. That is that. Okay? Now, let's delve into this a little bit more. 1 to anything, to the power of anything, is still 1. So that's just going to be 1. So what we're really left with is something, choose 2, 1, doesn't matter. I can write 1 times x squared, which is going to be x squared, because that whole thing is 1, so I don't need to write 1 here. Okay. So if we compare this to this, they have to be the same because they're both representations of the third term. X squared on both sides, which means this is the same as that. I'll write that in the next line. N over, and not over, n choose 2 is the same as 36. Okay. Now, at the moment, we don't really have, well, we haven't probably come across a question like that where we don't know the power of the series. Now, we could just use a calculator to guess this, start guessing. No, it's going to be a whole number anyway. All these would be integers, positive integers, so it's going to be a whole number. So you can start guessing. You know it's going to be a bit down Pascal's triangle because you kind of know, well, we know up to this line, Pascal's triangle, the third term is 10. So it's going to be a bit further down than that, probably a few down. So that was when it's to the power of 5. I know the third term is 10. Power of 6. The third term is going to, I think, what was it, 20. Might be the next one, maybe the next one after that. But what I'm going to do, so you could guess, you could start, and I'll show you that in a second if you start guessing. But what I'm going to do is I know that this is a formula for something. there is a formula for that, and we should have it in our notes. And I will write it again here. If I have the formula, it is the general formula for is got to do with factorials. And it was n factorial over n minus or factorial times or factorial. Okay. Okay. Now this is n and 2, not n and or. So I'll just put in 2 wherever or is. N factorial over n take away 2 factorial multiplied by 2 factorial is 36. All right. I move that. Okay. Now this is very similar to those factorials we were trying to simplify last week. Let's simplify this factorial as much as I possibly can. N factorial is, remember, n times n minus 1 times n minus 2 times n minus 3 all the way down until we get to 2, until we get to 1. That's n factorial. That's the top line. The bottom line, and hopefully some of you have seen where I'm going with this, n minus 2 factorial is n minus 2 times n minus 3, one less, times n. Oh, well, that's just the same as sum of the above. Sorry, it finishes at 1. And then there's an extra 2 times 1 at the end here. So it's double 2 times. But from here to here, 1 second. Sorry about that. Okay, so from here to here matches from here to here. We see that that will cancel with all of that because it's the exact same. So what am I left with? On the top line, I'm left with n times n minus 1, which is n squared minus n, if I multiply in that n, all divided by 2 times 1, 2. That equals 36. So I'm going to solve this algebraically with my knowledge of algebra. Multiply both sides by 2. I get n squared minus n is equal to 72. Now this is a quadratic. I can solve quadratics. N squared minus n minus 72 equals 0. Factorize. N and n comes from the n squared. Factors for 72, 9 and 8 are going to subtract to give 1n. Now, which needs to be positive? If I want to make negative n, I know that 9 needs to be negative and 8 needs to be positive. Looks like I'm going to get 2 answers for n here. This, n plus 8 equals 0, so n must be negative 8. Okay, that's one answer. N minus 9, n minus 9 equals 0, so n equals positive 9. So I do get 2 answers. Which one do I keep? Or do I keep both of them? Yeah, you keep the positive one, yeah. The negative one won't make sense. It doesn't make sense. It is a solution that works for this particular quadratic, but it is not a solution that works when we're dealing with factorials and the power here. Negative 8 wouldn't make sense here, because then that wouldn't be the third term then. The third term would have an x to the negative 7 in it. That wouldn't make sense. Okay. So we have now n is equal to 9. So we've gone a whole long way about finding n, but n is equal to 9. A quicker way to do that is, well, as I said earlier, if you just wanted to start guessing, more than welcome. If you didn't want to use this formula is given to you in a formula booklet, and we'll be getting the formula booklet soon. If I just want to start guessing, as I said, it's definitely more than 5 because our example had 5 in it. So if you just started to do 6, choose 3, oh, that's not enough. And then maybe you went 10, choose 3, or is it 2? Sorry, it's 10, choose 3, 2. Oh, that's too much. 6, choose 2 would have been too little. Okay, and it's somewhere between those, and you could have just guessed. You know it's a whole number, so you could have just guessed. Okay, so I still haven't finished the question. I found out n was 9, but the question wanted to find n, which I now have found is 9, hence find the fourth term. So this is 1 plus x now to the power of 9, find the fourth term. Okay, so that should be not too much of a problem. Is 9 the coefficient to the second term? As in, is 9 here? Well, you could find that out. Yeah, you could find that out. So it'd be 9, choose 2. And that's, you'd have to do that in your calculator. 9, choose 2. I think you might be right. Oh, I didn't need to press the wrong one. Oh no, it'd be 9, choose 1, wouldn't it? 9, choose 1 is, of course, itself. It's 9 factorial divided by 8 factorial. Although it looks like maybe 1 factorial, but it's 9 factorial divided by 8 factorial, which just leaves the 9 on top, and it is 9, yes. Okay. Because the first one would be 9, 0. The second one is 9, choose 9 and 0, 1, and the third one is 9 and 0, 2, which means the next one is going to be 9 and 0, 3. Once again, you can do a calculator. You could do it using the formula, but I'll just repeat this line and replace the 1 with 3. That gives 84. And there's nothing else to affect it. 84 from, and that is then 9, choose 3, which would be the next term. 1 to the power of whatever is going to be just 1, and x is going to be cubed. So it's 84 would be the 84x cubed is the next term, because once you should notice the pattern that x's are increasing, and that's the answer to the fourth term. Okay, and that was just a follow-on. The hard part there was to find n. Okay, so hopefully you followed that. A little bit for homework. I want you guys to do some of these. Tomorrow, we're going to look at exam questions, what they look like.